So in this video, we are going to solve one problem based on Routh's criteria, basically to determine whether the given system is stable or not. So examine the stability of the given characteristic equation. Okay. So Routh array we have to form. So Routh's array how to form. So basically, we have to here one more thing you have to remember. The powers you can see it is s power 6. It is given in decreasing order. If any power is missing, you have to consider it as coefficient as 0. So in Routh's array, you have to take only the coefficient. Okay, only the coefficient of that s variable you have to take. So here, how to form this? On the left side, you have to write decreasing order of the powers, s power. Starting with s power 6, it is the highest power given characteristic equation. Then s power 5 will come, then s power 4 will come, s power 3, s power 2, s power 1, s power 0. Like that it will go on. Now here let us form, and one more thing remember, from the characteristic equation which is the question given, from that you can form these two rows. First two rows you can form directly from the equation, that is the question itself. Okay, how to form that? One method I'll tell you two methods to write the first two rows. The first method is that you have to see the odd number of places first. The odd number of places is nothing but here, this is the first place, then you have to see third place, then fifth place, then seventh place. If it is there in this question, it is there. So 1 3 5 7, all the odd places, not odd powers, I am telling odd places. So that coefficients you write in the first row, that is 1 4 5 and 2. I am writing the coefficient, you can observe here 1 4 5 2. Okay, the second row you have to see the even powers, the left out one, even powers. So we are having here this one that is 3 6 3, right? So 3 6 3. So what about this one, this part if it is not there, you have to write it as 0. The missing one, always remember, you have to write it as 0. Second method to write the characteristic equation. So listen carefully here. First method was to by taking the odd position coefficients, odd position terms coefficient. Second method is something but you can directly go for one element, and remember the elements are in descending, powers are in descending order, and all the powers should be present. It is not like one power is missing. Suppose s power 3 is not there, then you have to write it as 0 s power 3, okay, in that place itself. Now all the powers are present over here from 6 s power 6 to s power 0 in decreasing order, descending order. So you can start with 1 3 4 6 like that. How to write? 1 3, always remember first two rows only we can write, okay, other rows we have to find out. So first two rows I am talking about this only. So 1 3, write it is column wise. Next 4 6, right? 4 6, then 5 3 5 3, then 2, then 2, here it is not there, then it is, that's it. Directly you can write 1 3 4 6 5 3 2 0 in order wise. Always remember, like this you have to take only first two rows, okay, don't consider this row. Now what about other rows? Other rows you have to multiply and write. How to do the multiplication? Let us see. So for s4 we have to write the element here. For this element, what you have to do, you have to multiply 3 into 4, always from bottom left to top right, always multiplication like this, okay, and 1 into 6 divided by this element. Okay, so basically, so I'll just do the calculation here. 3 into 4 minus 1 into 6 or 6 into 1. So always keep 3 into 1 3 into 4 first, okay, divided by the element itself, that is 3. So it is 12 minus 6 by 3, which is equal to 6 by 3, which is equal to 2. So I'll write it here. Now what about this element? This element, again the same thing. Always remember, this is the reference. These two elements are the reference. So multiplication will be 3 into 5 minus 3 into 1 divided by this element itself, that is 3 into 5 minus 3 into 1 divided by the element itself, that is 3. So it will be 15 minus 3 by 3, that is equal to 12 by 3, which is equal to 4. So I'll write it here 4. The next element, we have to see this one for writing this element. Again, this is the reference, as I said, 1 and 3. So again the multiplication will be this into this, that is 3 into 2. I'll just write it 3 into 2 minus 0 into 1 or 1 into 0 divided by the element itself, that is 3. So the denominator part is fixed for the this row elements. Okay. That will be 6 minus 0, that is 6 by 3, which is equal to 2. This element becomes. Now what about this element? Now here we don't have any elements here, correct? So you can directly write it as what? Okay. No elements here, that's why it is. Now let us go for this s3 row. S3 row we have to write. So first this one, that is basically for writing this part we have to consider these two elements. Okay. So initially we consider these two elements, now you have to consider this two. So again same thing, 2 into, so this is the element now, correct? In the denominator this will come. So 2 into 6. Okay, I'll just remove all this. 2 into 6 minus, that is 4 into, or 3 into 4 divided by what is the element here? It is 2. Remember this is the element now. That is equal to 12 minus 12 by 2. 12 minus 12 by 2, it is 0 by 2, which is 0. So I have to write it here as 0. Next 2 into 3, I have to write this element of 2 into 3 minus 2 into 3. 2 into 3 minus 2 into 3 divided by the element here, it is denominator will be 2. It is fixed for this row. That is equal to 0 by 2. Again same thing, 0. Again this is 0. Now next element, that is 2 into 0 minus 0 into, again it will be 2 into 0, it is 0, minus 0 into 0 is equal to 0. It is basically again 0. This element becomes again 0. The last element also will be 0 since there is no element over here. Okay. So this you can observe that this entire row has become 0, correct? So this we call it as row of 0. So whenever a row becomes, the elements of the row becomes 0, that means entire element of that particular row becomes 0, then we call that row as row of zeros. Okay, now this is a special case in which what you can do, now we have to replace these zeros with some other thing, some other coefficient. How to do that? For that purpose we have auxiliary equation A of s. So you have to form the auxiliary equation. How to form the auxiliary equation? Auxiliary equation is nothing but above the row of zeros, one more row will be there, above, not below. Below anyways it is not there. Above, just above the row of zeros, we have one more row. That is nothing but one row is there. Here we can see it is s power 4 for this particular question. So this row we have to write the auxiliary equation. How to write? Simple. This is s power 4. So this coefficient 2 we have starting. So let me just remove all this. So basically this is s power 4, right? So this 2 I can write it as s power 4. 2s power 4. Now what about this 4? Now decrease 2 powers. Decrease 2 powers. Next element will be 4. Decrease 2 power, that becomes s power 2. Initially it was s power 4. While looking at the left side we have s power 4. That's how I wrote 2s power 4. For 4 you have to write it as s power 2. Now what about 2? 2 I'll write it as plus 2 s power 0. Correct? Decrease. From 2 I will decrease, minus 2 you do. It will become 0. So decrease 2. For auxiliary equation you remember like this. The first element coefficient, write it with s power 4. Why am I writing with s power 4? On the left side you can see it is s power 4 row. The starting element will be s power 4. Decrease 2 that means subtract 2 from the powers in order to write the entire this thing. This is anyways it is 0, so no need to write. So our auxiliary equation has become this one. Okay, this is important how to write. Now next thing is nothing but we have to differentiate this auxiliary equation. To differentiate auxiliary equation, that is important. So that becomes with respect to s we are differentiating. So before that you can do one more thing, that is nothing but in this equation we have 2 as common. Okay, so take out that 2 and cancel out. That means this one becomes, now I have to put this auxiliary equation equal to 0 in order to find out the equation, right? So I have to put equal to 0. Okay, now we have to differentiate this auxiliary equation with respect to s. Before that I can do one more thing, I can just simplify this equation by taking 2 as common, right? So I can write this equation as s power 4 plus 2s power 2 plus 1s power 0, which is equal to 0. This becomes the equation. I have just taken 2 outside and just bring it to the RHS side. Anyways it is 0, so it get cancelled. Okay, so this is my equation. Just simplify it. Now you differentiate this equation, it becomes 4s power 3. I hope you know how to differentiate. S power 4, bring for this side, that becomes 4s power, subtract from the power 1, that becomes 4 minus 1 3. Okay, plus 4 2s power 2, bring this power this side, that becomes 2 into 2, one more 2 already it was there. Okay, 5 s power, subtract 1, it will become 1, so it will be 4 s power 1. Now here anyways it is 1 s power 0, or we can say it as s power 0 is nothing but 1. It is a constant term 1. Constant term differentiation is always 0, so no need to write for this one. So our differentiated equation is this. Okay, 4s cube plus 4s power 1. Now this equation, this coefficient of this equation, after differentiating you can put it in the row of zeros thing. So basically what I am going to do, I am going to delete this row of zeros which was the elements were 0, and I am going to put here the differentiated coefficient, that is nothing but here I have 4, here also I have 4. So this is s power 3 row, right? So 4s power 3 came here, and this element will be 4s power 1. As I said before, the thing is that the powers will get subtracted by 2. Okay, that's it. 4 and 4 I wrote. Basically I have written from coefficients you have to see. What about the rest elements? 0. Let us go for, so this row of zeros has been deleted, so we have basically removed the row of zeros. Now let us go for s power 2 row. For that again this element multiplied with 4, right? So 4 into 4 minus 4 into 2 divided by, what is the element here? 4 is the element. So for this row 4 will be fixed in the denominator. So 16 minus 8 by 4, 8 by 4, which is equal to, I'll put it here 2. Now next this one I have to find out again, 4 into 2 minus 0 into this one. So 4 into 2 minus 0 into 2 divided by 4. So 4 into 2, 8 by 4, which is equal to 2. Again this element becomes 2. Next, for this element no need to find out because these two are zeros anyways, so no need to multiply also, this will be 0 and this. Now let us go for s power 1. This element I have to find out first. So 2 into 4, so 2 into 4 minus 2 into 4 by, what is the element here? Now the element has become 2, that is equal to 0 by 2, which is equal to 0 here. Okay, now next thing, a little bit confusing, so I have just removed all the things. So 2 into again 1 0 minus 0 into 4. So 2 into 0 minus 0 into 4 divided by 2. So basically again it is 0 by 2 which is equal to 0. This is again 0. What about these two elements? It is anyways it will be multiply and see also it is the same. So basically here if you observe again the one more row has come where all the elements are 0. Correct? Again one more row of zeros came. This is row of zeros again. What you should do now? One more row of zeros came. Basically now what you have to do? You have to again take auxiliary equation. Okay, not the previous auxiliary equation. Now you have to take for this particular row of zeros, right? So the row before this row of zeros you have to take the auxiliary equation. How to take? So again the same thing. This row if you see here we have 2 2 0 0. Correct? So 2 and 2. Here you can see the power, it is s power 2. So with this I have to take s power 2. So auxiliary equation becomes, I'll put a dash. This is the second auxiliary equation. Simple notation. Equal to 2s power 2. Remember whatever the side we have in the side of this thing, whatever the s power is there, that only you have to take. So this becomes s power 2. What about this 2? Plus 2, as I said before, it power is 2, I have to reduce 2, that becomes s power 0, plus no need to write, anyways it is 0. Okay, 0, so no need to mention that also. So our equation has become 2s power 2 plus s power 0, anyways it is 2 only, that means it is 1. Okay, so this is the equation equal to 0. Now this equation I have to differentiate, right? Differentiating this auxiliary equation with respect to s, what will become? 2 into 2 it is 4, s power reduce 1 power, that is 1. Constant term anyways it is 0. This is the differentiated equation. Now what can I do? Now I have to remove this row of 0. Okay, now I can remove this row of zeros, delete this row of zeros, and I'm going to put what? I'm going to put the I'm going to put in place of here, earlier it was 0, right? I'm going to put here 4. Only one term is there, 4 s power 1. Here also you can observe this is s power 1 only. So 4 here. What about these places? It will be 0 0 0 because we don't have that term. So this, the row of zeros has been deleted. Now let us continue further. Now here we have to find out this element, correct? So 4 into 2 minus 0 into 2. 4 into 2 minus 0 into 2 divided by, what is the element over here? It is 4. That is equal to 8 by 4, which is equal to 2. So this has become 2. Okay. Now what about this element? 4 into 0 minus 0 into 4, it will be 0 only. Okay, this is 0. This also will be 0. This also will be 0. Same method. Remember one thing, that this is s power 0. In the question if you see, s power 0 coefficient is that only has come here. So remember this thing. In order to understand whether you have done correctly or not, just see the last power, not the previous one. The last power, that is s power 0, whether the coefficient is there or not. 2s power 0, correct? So 2 is here. That means your then the method of doing is correct. So always remember, whenever we are getting, this was the special case where we had a row of zeros twice. So no need to worry about whether it is coming twice or thrice. Only the same condition, same method you have to apply. What? Whenever we are getting row of zeros, you have to consider the auxiliary equation, differentiate it, and remove that row of 0, put the terms wherever it is there with the differentiated terms coefficients. Now we have to examine the stability, right? So basically if you see here in this question, basically we didn't get any sign changes. So therefore we can say that whenever there is no sign change, the system can be stable, but we are not sure. Now this system can be marginally stable or unstable also. Okay, so in order to identify that, we have to see the roots of auxiliary equation. Okay, so whenever we are getting this type of problems, so we can say that no root is located on the right hand side of the display because there is no sign change. No sign change means that the sign change basically means you have to see the first column. Okay, first column, if you observe, all are positive. There is no sign changes. That is nothing but positive, negative, positive, like that. There is no sign. Only all the signs of the first column, if you see the routes array, we are observing that it is only positive. That means there is no sign change. Okay, and so since there is no sign change, we can say that no root is located in the arches of S plane. Okay, but the system may be marginally stable or unstable. Now we have to identify whether which one of these is true. For that we have to find the roots of auxiliary equation. Now we had two auxiliary equation in this. Always remember you have to take first auxiliary equation in these situations. Okay. So first auxiliary equation, if you remember, it was nothing but s power 4 plus 2 s power 2 plus 1 equal to 0. Correct? Or 1 s power 0 also you can. For this I am going to find out the roots. Since it is s power 4, I will just substitute s power 2 as x. So I can rewrite this auxiliary equation as s sorry x square plus 2x plus 1 is equal to 0. Simple. I am just replacing s square as x. That is why this has become x square plus 2x plus 1 equal to 0. Now I can simply solve this equation. This is quadratic. I'll apply quadratic formula. So quadratic formula basically means minus b plus or minus square root of b square minus 4ac by 2a. So that becomes minus b is nothing but this one. So minus 2 plus or minus square root of b square, so 2 square minus 4 into a value is 1 into c is 1, nothing but this one constant, divided by 2 into coefficient of x square, that is 1. So this becomes minus 2 plus or minus square root of 4 minus 4 divided by 2. So 4 minus 4 is nothing but 0. Final answer will be minus 2 plus or minus, no need to write, is 0. So minus 2 by 2, which is equal to minus 1. Okay. So basically this is nothing but s square value. Why? Because we have found out x value, right? X value we got minus 1. Okay. That is nothing but x s square. We are getting what? We are getting the value of x only. Correct? So x value should be, two values should be there. Since it is quadratic, we are finding out the finding out the values of x for this quadratic equation. Quadratic means how many roots should be there? Two roots should be there. That means x value should be minus 1 comma minus 1. Same roots we are getting because we are getting only one value minus 1. So you have to write it as same roots, minus 1 minus 1. Two roots should be there. That is the thing. Okay. Now, but the thing is here is that we are having this, we have to find out for this equation, right? S power 4. So s square is nothing but x, which is equal to minus 1 comma minus 1. So I can write s square as minus 1 and s square as minus 1. So what is the value of s? S will become square root of plus or minus minus 1, and here also s will become square root of plus or minus minus. That is nothing but I can write it as plus or minus j, and here also plus or minus. Why am I getting 4 roots here? Because always remember you are finding out for s power 4. S power 4 means what? How many roots should be there? 4 roots should be there. Okay, starting basically I replaced s square with x so that it becomes very simple for me to solve. Quadratic equation is simple for me to solve. Okay, so I have solved using the quadratic formula and I have got the values for x. Then I have substituted for s square is equal to x. I am getting here four values. What are the four values? Plus j, minus j, plus j, minus j. Correct? Four roots I got. As I said before, if you try to draw the s plane for this particular thing, this particular system, this is the imaginary part, this is the real part. So we are having only the roots for imaginary, that is 1j minus 1j, like that. Okay, so one let us assume here it is 1j imaginary part, right? I'll write it as plus j, here it is minus j. So basically in order to represent, you can represent, basically we are having the same roots twice here. So I can just put it one here, one root here, another root beside this I can put, that is basically I can put like this, plus j. And here also same thing. This basically denotes that we are having two roots at the same position, two roots at the same position. So we here, you need to understand, we have to solve only first auxiliary equation. No need to solve the second auxiliary equation, since the second auxiliary equation roots, that is a dash of s equal to 0, are nothing but the roots of a of s itself. Okay, so no need to solve for that second auxiliary equation. We have to predict the stability of the system from first auxiliary equation only. Okay. Here we can say that here we are getting repeated roots, right? Here we are getting repeated roots, correct? You can see, observe here, we are getting repeated roots that are on the imaginary axis, not the real axis. Okay, so since we are getting repeated roots, always remember, when you are getting repeated roots and it is on the imaginary axis, the system will be unstable. So we had two options, right? First option was either it will be marginally stable or unstable. Okay, so by solving the auxiliary equation we found out the roots, and the roots, nature of the roots, what was the nature of the roots? The roots are repeated and on the imaginary axis it is situated, therefore the system is unstable. Always remember, imaginary repeated roots.